Hello and welcome. Who is ready for Sets Ed? Woo! So as Denny mentioned this morning, set actions really aren't about sets at all. They are about interactivity. Interactivity is a core component of rich analytical systems because it helps answer deeper questions, solve more end-user tasks, and design better end-user experiences. More expressive interactivity means that you can deliver richer content to audiences, such as clients and stakeholders. And interactivity creates playful experiences that drive engagement and curiosity. And these are the things that are going to help spread data literacy throughout the world. My name's Bethany. I got rid of my job title and replaced it with this one here. If I do my job well over the next hour, you will see why this is not a new feature. This is really a movement and a huge shift in the entire interaction paradigm of Tableau. So before we start with what's new, let's just have a quick review of what is the existing interactivity in Tableau today. So today we have 3 types of actions. You have filter actions, highlight actions, and URL actions. For each of these actions, as a user, you can configure the source and the target. But filter actions always filter, highlight actions always highlight, and URL actions always launch a URL. And so in the existing actions, every action type is bound to one single behavior. Now, sets are not just a new action type. They are completely different from these other ones because now with a set action, you are simply storing a selection in a set. And a set can be used anywhere. It can be used on the filter shelf, like filters, but it can also be used on rows or columns or color or in a calculation. And so what that means is that as the author of the action, you design the behavior of the action. And so your target can be pretty much anything. It's up to your imagination. You can now group or color by a selection instead of just highlighting by a selection. You can hide what is not in a selection if you need to compute a specific order of operations. You can use a selection in a calculation. And so things that you can do with that is, for example, filter a single axis in a visualization as opposed to filtering all of the fields in your worksheet. You can filter a single term in a calculation, such as applying a set to a numerator. You can select a related field. So rather than applying your filter based on the selected value, you apply your filter based on its relationship with another field. You can create dynamic groupings and merge different levels of detail on the fly or apply a conditional aggregation. You can express custom logical conditions. Our filters are always anding every single condition together, but if you need to OR several operators, you can apply that kind of logic as well. And these are just some of the things, but the list goes on. And so my view of a set actions, because of this power, is it's like if artists were granted entirely new color palettes. If ultraviolet light suddenly became visible, what would they paint? And set actions are very much like that. That is what they have done for visual analytics. Okay, by virtue of being able to express unlimited behaviors. So let's look at just a quick review of sets and how they work today. So you have a set as part of your data source and then multiple sheets. So today you can have that set color one sheet. You can have it partition or group by another sheet. And you can have it filter an axis in another sheet. So today you can have sets applied to sheets. The novelty of set actions and why sets have been liberated is we've now made this communication bidirectional. And so now a selection in any one of these sheets can update the set. And then since the set is applying to other sheets, a selection in sheet A modifies the behavior in sheet B and C while also applying 3 different action types. And so the way to think about what is a set is it's really like a multi-select dynamic parameter. It's tied to a domain, and it can easily be multi-value. The thing that makes parameters so powerful is that they are, up until now, they were the only way that you could take an end user selection and then design the resulting behavior of that selection. Now we can do that through sets. And we can do it in such a way where one selection coordinates and synchronizes multiple visualizations. This is the core of what makes a parameter so powerful. So now we have, for many cases, not all, but many cases, something that is like a multi-select dynamic parameter. Silence. All right, so let's jump over and look at some examples of what this is doing. So here I have some data from the World Cup, and it has the market value of every player and every team in the World Cup here. So that's what is being displayed on color in the map here. So if I now select France, this is now displaying that France represents 10% of the market value of the global World Cup, but only 3% of the teams. If we look at all of Europe, we can see that Europe is 66% of the market value, but only 44% of the teams. On the other hand, if we look at, for example, Asia and Australia, and then some of our North American countries here as well, here we see that all of these countries, while they represent 25% of the teams in the World Cup, they're only 5% of the market value. So there's, embedded in the interactivity of this very simple dashboard is in fact a Pareto concept. Without having to present to people a cumulative distribution function that freaks them out and makes them run away, you can give this to an executive on a mobile phone and know in your heart of hearts that they are interacting with statistical principles. And so this for me is the biggest thing of set actions, is that we can now use it as a way to engage more people, not just in data, but in correct reasoning about data. So let's just jump out and look at what would a filter do here. If we applied a filter, it just tells you the absolute number and says these 8 teams are 434 million pounds. Well, to me, that sounds like a lot of money. But it tells a very, very different story when you look at their proportional representation of market value versus what they represent as a number of teams. Who's excited about this? With flags, no less. All right, so let's look at how we rebuild this from nothing. So first we're going to look at the countries and then the market value of those countries. So I want to be able to make a selection and then have that be used in other visualizations in a way that is not a filter. So let me start first by selecting France here, and I'm going to go create a set. So at the moment, this is hard coding this set value to France. So let's call this our teams. OK, so now I'm going to use that in another visualization where we look at the market value split out by teams. And then we'll go put this on label and add a % of total and put this one on our label as well. So far, this is something you can do in Tableau today. So now let's bring these views together. And so this is the point where we're going to set up the action. So what we're going to do is instead of, at the moment, if I click on things, nothing happens because that value is hard-coded to France. But I'm going to just link this sheet to that set by adding a set action. And so the market value by country is now going to target this particular set here of teams. And so now when I go and make a selection of countries here, it's updating that dynamically without any calculations. This is pure drag and drop. Now, if we want to add in this other view that looks at the number of countries or the number of teams that are represented by that selection, let me make sure I'm using the same data source here. So if we look at the number of countries and then split that out by our teams, here we go. So now if we add this to label and add our % of total, it's also dynamically updating this view as well, right? So we don't need to go and add a separate action because that one set is being updated by this selection. And so this is the core of that idea where you can have one set do many different things on many different sheets. So there's that first example, super simple and no calcs whatsoever. So let's look at what's the next step of evolution on this example. So here I've added in one more visualization. And so this is showing you the market value by different player position. So center forward players are the most valuable players in the world. They're worth 1.5 billion pounds. So if I go then and select Argentina, now what this is showing is something quite interesting. Argentina is, while they're only 3% of the teams and 7% of the market value, they represent 23% of the global market value of right-wing players. Anybody know why? It's Messi, yeah, exactly. And when you look in the underlying data, you will exactly find Messi worth 162 million pounds. So like well over $200,000. So quite a lot. Now if we go over to instead look at Europe. So let's start adding some countries here. And so every time you add a country, it's adding to that that kind of proportion of total. And so eventually you see here that we get to over 50% of the market value of the entire World Cup team just in this small selection of Western European countries. So let's just go and add all of Europe. And here we see again it's 66% of the market value and 44% of the teams. So how do you interpret this? Well, anywhere in any positions here where Europe is over 44% means that relative to the world, Europe is better at those positions. Anywhere where it is over the, so look at the center forward here, for example, and you can see that center forwards are 66% of the market value, which is exactly equal to what Europe represents as a proportion of the total. So if you want to compare within the positions, like which positions is Europe best at relative to itself, where it's equal it just means nothing. So the interesting case is to look at the extremes, so where it deviates from that 66%. So here you can see that Europe is 83% of the world market value of right-back positions, while it's only 47% of the market value of right-wing players. And so, that tells you that Europe is relatively good at right-back and relatively weak at right-wing. However, if we were to look at this just in the way that you might if you're filtering, so I've sorted this now by the selection, so by the blue bars, which is the only thing you'd see if you applied a filter. So if looking at it in this way, you would just see the absolute value and say, Europe has more valuable right-wing players than right-back players. And while that is a true statement, it is not an interesting statement, because in general, right-wing players are more valuable than right-back players. And so the interesting story here is that Europe is relatively weak because right-wing it's ranked 4th in the world, while for Europe it's ranked 6th. And so again, you can now use, it's not just about proportional brushing, it's about being able to interpret data much more correctly than if you're just filtering and reporting on what the number is. It is the analysis of differences and the comparison to a baseline that is required in order to draw any kind of conclusions or interesting insights about the data. So again, this is why I'm so excited about this new capability. Silence. All right, so to add to this, our previous example here, now we can grab our market value, split it up by our different player positions, and add in this team set here. And then let's just go and sort these, put this the other way, and let me just make this a little bit lighter gray. Okay, so now adding this back into our previous dashboard, so let's put it, where should I put it? Somewhere like here, that'll do. now you can see that it's directly, again, updating this view as well. So we have the proportional brushing working. So now the interesting thing is, how do we make this so that you can sort and make those comparisons of percents of total versus selection versus overall? So if we come back to this view here, I'm going to just pick something a little bit more so we have some more data. Where was it? It was this one. All right, let's just pick something a little bit more blue. All right, so in order to be able to sort by those 3 different fields, selection, overall, or percent of total, we need to compute those 3 values. So we already have the overall market value. That's what this bar is giving you. So now we need to compute just the blue part as its own metric. And so we can do that through a calculation that conditionally returns the market value just for the players that are in the set. So the way that this works in the calcs syntax, and I will confess that this boggled my mind when I first learned this a few years ago. The syntax is if set, then return the market value. And so the reason this is the way that you express this is because a set is in or out. It's equivalent to a Boolean, which is true or false. So in means true. And the statement that always follows the if in your logical conditions necessarily has to be a true or false statement. And so therefore, a set is a true or false statement, and that's why you can reference it in this way. So this is now giving us the market value for our selection. And so if I go and apply that and bring it into the visualization here, you can see that that is giving you exactly, it's just separated out into a separate field, the market value of your selection. And so our percent of total is now going to be the market value of the selection divided by the overall market value. And let me just go and drag this off, and then you can see that that's giving you a percent of total. So let's go and persist this into our data model. I will add this is being recorded. So no fear if you're like, what? This is going so fast. All right, it's very high octane. I'd rather show you a lot of awesome stuff than spend too long on the calcs. All right, so now we have our 3 measures, and so we just need to tie it to the parameter so that the parameter knows which measure to return based on the selection. So we can do that through a case statement referencing this sort by parameter, which just has those 3 values. So when it is set to overall, then we want to use the overall market value. And then when it's set to the selection, then we want to use that, let's call it a cohort calc. And then in the last case, we want to use our percent of total. And so this is now going to be the thing that we use to apply a sort. So you'll apply this as a computed sort on the position. So by field descending by the sort. And so you'll see here that's now modified this to sort by the blue bars. And if we put it to percent of total, then it modifies to sort it by that last bar. So we don't need to keep all of these in the visualization. They're just being used as a way to express that sorting logic. And so now we can go and just drop on this percent of total. And we want to compute that for every position. All right, and so now if we go back to our dashboard, you can see that we have that example completely rebuilt from scratch with 1 calculation, no, 2, 3 calculations, and here we are. So there you have it. Who's excited to go add all kinds of proportional brushing to their workbooks? All right, now I have to say I'm a perfectionist and I'm eternally dissatisfied with my work. So I looked at this and thought, there is a better way. So you may have noticed when we were looking at our right back and where was the other one? Right wing players. And modifying the sort by the selection versus overall. You're essentially in toggling between selection versus overall, you're trying to see, well, what's the difference in the rank between just Europe versus versus the rank of these positions in the world in general. So you can do that by trying to kind of visually observe where things jump as you make a selection. Or you could just build a viz that does that. So I opt for option 2. So here we have, it's like the angel viz. It looks like it's got wings. So here you have on the left side, it's showing you the rank in the world overall. So center forward here comes out top globally. And then in the view on the left, it's showing you the rank of positions within our selection, so in this case in France. So here this shows you that France's top position is right wing, while right wing is ranked 4th overall. They have both the same, France is the same as the world in general in 2nd and 3rd position, but then it's 4th in the position that the world in general is 1st in. I think another interesting one here, Belgium has like the coolest one with this really nice crisscross view here. So their right-wing players are 9th, while it's 4th in the world in general. So who wants to see how to build this? Yes! All right. So the nice thing about this is no calcs. You can do this just using the calcs that have been created in the first part. So the first thing we want to look at is, by our different positions, the market value for our selection. So that's that calculation that we'd made. And so we want to be able to rank. We have to compute the rank for this. So we'll just add a quick table calc that does a rank. And then we also need the rank for the overall market value. So I'll bring in overall market value and add a rank for that. And then these are the things that we want to compute the difference between. So we'll take our overall market value rank and then subtract our rank for our selected country, so for France in this case. And so then let's just go and persist this into our data model. So that's the rank for the market value. And then this is going to be, sorry, that was rank for, I should rename that. This is rank overall. And this is, let me rename this so I don't get confused. This is the rank for our selection. And then this is going to be our difference in the rank. Okay, so for that left part, or the right part of the angel wing, we just need the market value for the selection, and then we'll color it by the difference. So, and I think I actually want it to be, yeah, that's right. No, that's right. Okay. Oh, yes, and then just a couple little formatting things. We'll hide this, and then just label it with the position. So then for our overall value, we want the total market value, and then we want to break that down by the position. And then a neat trick is you can reverse the axis just by putting a negative in front of this. And then we'll just go and hide this header, put that on label, and unhide this. And you can say, don't put this in the tooltip because it doesn't make sense, but you can add back the market value overall to the tooltip so that you still see numbers that make sense even though your bar is reversed. And so then for our difference in rank, now we want to take those two ranks, so the overall rank and then the rank for our selection, and then split that by position. And importantly, we want to compute the rank along the positions. And then we want to compute the difference as well and color by that along our different positions. And then we'll just go and reverse this so that the top ranked positions are up top. And we can go and swap the order of these things here. And let's just go and hide these axes. And so now, when we come to here, we'll bring in our wings, and then the crisscross, and let's just get rid of those, and then we can add back that map. And so now we just need to set up the interactivity so that clicking on the map updates this right-hand view. So we'll do that through the set action. And so you can have multiple different visualizations updating the same set. So this will update the proportional brushing view that we made before, giving you that coordinated, synchronized experience. So we want specifically the market value per country to apply to the team set. And so then now as I go and make a selection, actually that doesn't make sense in Multiselect really. And so yeah, now we can go and make these different selections. And notice what's happening here is only the one axis. So I mentioned in the beginning, you use sets if you want to filter a single axis in a visualization. That's exactly what this is doing here. You'll notice that this side is fixed. But as I make a different selection, it's just the right side that's recomputing. So this is an example of how you can use set actions to filter a specific axis of a visualization. All right, now things start to get exciting. Okay, so here, this one is, I think, yeah, probably my. This one is, so let's do Brazil versus Germany. Okay, so this example here is showing how you can perform a part-to-part comparison. So at the moment, I've selected Brazil, and so this is showing the average market value of a Brazilian player, almost 40 million. And then Germany, the average market value of one of their players is 34.6 million pounds. And so then, now what if you want to compare their market values split by players? So this number here corresponds to the vertical axis, and this number here corresponds to the horizontal axis. So it's then splitting it out by different position, so you can see which one of these teams is better at which positions. So for example, here, attacking midfield, Brazil's average player value is 90 million, while Germany's is 45 million. So then the difference of 45 million, it's not, the difference whether it's positive or negative doesn't tell you good or bad, it just tells you who's it in favor of. So orange means in favor of Brazil or whichever country you pick on the vertical axis, while blue means it's in favor of whichever country you've selected on the horizontal axis. So you could also compare this to the overall. So if I deselect this, this is showing me Brazil versus the world in general. And because you're looking at averages, not sums, it's totally fine to have a differing number of selections in each comparative group. So here, this is telling you that the only position for which the world is like better on average than Brazil is center back, but they outperform the world on average in every other position. We could also do things like say, well, France and Spain, so I want to compare the top two teams in Europe to the top two teams in South America. So France and Spain versus Brazil and Argentina, for example. And so then that's now showing you the average of across those two teams. So South America, the best two South American teams are better at left wing and center forward, but the best two European teams outperform in all the other positions. So what makes this scatter plot special? And what makes this scatter plot different, other than the fact that it's kind of colorful? So in the underlying data source here, so let's go and just do here France versus Spain, for example. Okay, so in the underlying data source, we have a field for the country and a field for the market value, right? So we have one dimension and one measure. But in order to create a scatter plot, you need to have two measures, one for each axis. So somehow we magically need to create two measures out of a dimension and a measure. And so that is exactly what's happening here. So you can see that there's two sets. There's a set on country 1 and a set on country 2. And so what it's doing is returning the measure. It's creating two new measures. And in the first one, it's returning the market value for the countries that are in the first set. And in the second one, it's returning the market value for the countries that are in the second set. So we've basically created two measures out of a dimension and a measure. And so it updates. So as I go and pick Croatia, it dynamically updates that second measure. And so that's why you're able to plot this on a scatter plot, despite not having two measures in the underlying data. All right, who wants to see how this is built? Woo! All right, so let's go and start with our legend map. So if I go pick France, let's say, and I want to go and create a set out of this. So this will be our country 1. All right, and then let's go and just drop this on the filter shelf, and then let me go and duplicate this, and then make another one for country 2, so let's say Brazil. And so that becomes country 2. And then I'll put that on the filter shelf here and make this one orange. So these are our two kind of legends. So now for our scatter plot, we need to create those two measures out of our country and our market value field. So we need to conditionally return, let me make this a bar, it'll make more sense. Okay, so we need to conditionally return the measure if it's in the set. And so you'll notice that this is basically, yeah, you really only need to learn one calculation in order to do anything with set actions. So it's the same as what we did in the other example. So if it's in the set, then return the market value, and then otherwise leave it null. And so that's going to give you your market value for country 1. Okay, and so you'll see what it does is just kind of slice out that bar for France. And then we can just duplicate that and then look at the same value here, market value for country 2. I'll just replace the set to reference the other one. And then that is going to slice out the bar for Brazil. So now we have two measures. So then we can go and turn this into turn it into a scatter plot if we put it on opposing axes, and then bring in the position, and then go, and the size was the number of players, and then the color was the difference between these two. So just compute the difference here by saying take the market value of country 1 minus the market value of country 2, and then chuck that on color. And I think I need to reverse that actually. So there we go. And then to add the reference line, so it's not, if you add a trend line is a statistical computation of correlation. I'm not trying to correlate, I'm trying to compare. So I don't want a statistical trend line, I want an x equals y line. And so a nice trick you can do is just put the same measure on opposing shelves, and then if you remove the stuff and add the trend line to that, because they're perfectly correlated, you end up with an x is equal to y trend line. And then just overlay it on a single chart here. Nice, cheating. So then, to go and build this out, we'll bring in the scatter plot. I've then got my my axes here. So these are just really simple heat maps, and can add a little blank thing down here, and voila. So now the trick is, once again, to just add the set action, because everything I've done so far you can do in Tableau today. It's just not interactive, which is the key requirement in general when you're sharing this out with a number of people. So let's add in our little map legends here that kind of give a visual indication of who are we looking at. And so then we go and add the set action here. So in this case, we need two set actions because we're updating two different sets. So we want country 1 to update the, no, not this one. It is number 3, number 2. Okay, so we want that to update country 1. Why is it missing a field? Let me go see. What have I done? I built it on the wrong data source. So let me just quickly put it. Now you get to see how this thing's built because I messed up in my preparation. Then put that on label, and then it was average market value on color. All right, and then go and sort those, and then hide this thing. All right, you try and save time, then do it wrong. All right, so it was this data source, and average market value, and let's go sort those and make them orange. Okay, and we can hide that. Cool, so this should work now. So if we go and add those actions, that one's happy now, and so then we'll add another action for country 2, and we want that to target the country 2 set. So now we can go and say, how is Argentina comparing to Uruguay. And boom, there it is, rebuilt from scratch, before your eyes. All right, so let me give you an example of another type of, in fact, it's exactly the same problem, but it just looks really different application. So a really common type of analysis people want to do is year-over-year growth or comparison from period 1 to period 2, and then show what that growth is broken down by something else. So here we're looking at London house price data. And so you can see this is comparing year 2000 to 2008. So this is normalized house prices to account for inflation. So the house prices actually decreased by £55,000 on average over that 8-year period of time. However, in certain boroughs, this is where I live, in Newham, it increased by 17%. And then this view here is just giving you, it's like a visual calculator to tell you that the blue range corresponds to the blue period, the black one corresponds to the black selection, and then these two reference lines are computing the average just within that specific range, and then it's the difference between those two lines that gives you your difference. So then you can see, if we add in a few other years here, so compare 2000 to 2008, 2009, 2010, it actually took, 3 years after the financial crisis for the house prices to get back to the place that they were at in year 2000. So it's exactly the same principle where you have two sets, one for your period 1, another set for period 2, and then you conditionally return the market value based on your selection and then difference those, or take a percent difference, and then you can slice it by the district. So it's exactly the same calculations to build something like this for an analysis of change over time. This one here is looking at a difference from average. So here we have the market value by different teams in the World Cup. And so if we make a select, and then the right view is showing you the difference from the average line, so from this 294 million. But what if you wanted to do something like see what is the difference from the average across Spanish-speaking countries, for example? Well, then I can go and select Spain and Argentina and Uruguay and Colombia and Mexico, Costa Rica, Peru, Panama. And with every selection, it's recomputing the average across those selected countries. So before, you could always compute a difference from average, but your average would be fixed to the entire partition of data. Whereas now, your average can dynamically recalculate based on a selection. Who wants to see? Yes! All right, so we're going to go rebuild this one. So we're looking at the market value by different country. And then if we add in this average line here, essentially we want to compute the difference between the bar and the line. However, not between all bars and the line, or sorry, we want this line to update as we make selections. So unfortunately, we can't just take the reference line and use it in calculations. I wish we could. But essentially that you can use the Tableau's automatic reference line recomputation to validate that the numbers you're getting are right. So that's a good thing. Okay, so same drill. We first need to go and create a set on our country so that we can capture the selection of the particular team. And so I've now selected Croatia. And so then we'll create the exact same calculation that has been done in the other examples. So return the market value if it's in the set. And so this is market value for the selection. And you'll see that then just returns that one bar. So now I need to be able to take that number and then propagate it across all of the other rows so that I can do a row level comparison, comparing this bar to that value. So the way that you can do this is through a a window average calculation. So if I take the window average, basically just means look at the summary data in my visualization and then just compute the average across that. So to take the window average across this, this value here, and this is going to be the average across the selection. And then I'll go and apply that and bring this into here. So now you see it's copying that value across all of the other rows. So we don't need this one. That's the one that we want. So then to compute the difference, you'll just take your market value and subtract the difference from that. That's going to give you your difference from the average, and then we can go and put this on color, and you end up with this nice, nice view. Now, at the moment, it's not recomputing because I haven't yet set up the set action. So that's the final piece here, is to set up a set action whereby this difference from the selection of the viz itself is targeting its own set. And so now you'll see that if I go make a selection here, it's updating the set, which is then updating the computation. Now, I should add at this point that in the next couple of weeks, we're going to be rolling out, it started as a blog post, it's turned into like 5, maybe a website, a training platform. It's like 40 videos and 20 examples, maybe 50 videos. It's a lot. And so it goes through all of these things at a slower pace, and you can hit pause. And it'll talk through some techniques to work around little niggly things, like you'll see here, because I'm making a selection of the 3, it's highlighting those, but actually I want it to highlight everything. I want to see the entire partition. So I'm not going to go through those things now, just because I'd rather show you more examples. So yeah, you'll have, actually they're on my Tableau public profile right now, so you could go watch it after this session if you want to figure out how do you make it highlight the whole thing. So other kind of applications of this same problem here could be looking at the difference from average in a the average price in a particular postcode. So where's E15? This is where, somewhere right here. There's where I live. And so now it's going and computing it's picking up the average price in that particular region, which I do not own a property in, and then computing for every other postcode, computing the difference from that selection. So you can kind of baseline every other postcode against a particular postcode. Now, because sets are multi-select, you can also do interesting things like say, well, how does London compare to how does London compare to all of the west side of London? And so it's gone and actually created this custom grouping using custom geographic roles, and then computed within that kind of slice of West London, the average house price is nearly £1 million. And then it's differencing every other postcode from that selection. So only the orange ones are the ones that have a higher average price than across that selection. Whoops, whoops, whoops. I went too fast. All right, some other things you could do here. Oh no, I've gone way too far ahead. All right, other things would be conditional aggregation. So here we have, let me put this in a bigger view here. So here we're looking again at London house prices by district, and then the moving average of normalized house prices over time as a summary view. Now, what if I want to see Kensington and Chelsea? So when I click on it, it breaks down the moving average by Kensington and Chelsea, and then also shows what is that compared to all of the other districts. And so then as you start to add other districts, it's conditionally breaking them down and computing the other as everything else that's not in that selection. So if you were to apply a filter instead, you would need to start with this every district on color. So you'd have like 25 colors and no summary, and the filter would just remove lines, right? So this is much more powerful because it gives you the overview until you click, and then it starts to break down. So it's it's using your selection to disaggregate the data as opposed to just filter it. So that's an example of another type of behavior that you can, or action type, that you can set up through set actions. So how this works is it applies our one calc that you need to know, which is so there's a set on the district, and if it's in the set, then return the district. Otherwise, group everything in this other category. And then that's the thing that's on the color to break down the line. Silence. All right, this one, I hope you guys are going to get fired up about this. So here we have the average player value by group G, or by different groups in the World Cup. So I wonder, what's happening in group G? Just click the bar, and it automatically drills down to the country, and then to the player. I can go up to a different one and say, well, what about in Belgium? Or actually, I'm interested in just breaking down by group A and Uruguay. And so you can seamlessly drill down and up and explore the data. It gets better. All right, so what about on a map? So here we have the house prices across all of England. So what if I want to drill into a specific region and see what's the median price within the East Midlands? Well, I will just select this, and then it automatically zooms down into the next level. Yes. All right, this one I made for Jonathan Drummy, who's sitting at the front here. He built this for, it was a malaria visualization for Bill Gates. And Bill Gates has spent something like 10 minutes just playing with it, but he had to turn a database inside out and union it to itself 100 times. And this is really, it's only hard, not impossible. And so, yeah, then we can drill down to another level. This is literally how counties are organized in England. That's what 2,000 years of feudalism will do to a country. Reset it back to the second level, then go down one more, then reset to the highest level. And so there's another one. Yeah! All right, this one's less beautiful, but possibly one of the most useful ones. So here we're looking at the bars represent every player in the World Cup, and then they're ranked in different tiers. So there's the rank that they have within their team, the rank within their region, and then their overall rank as well. So I want to see all these different ranks. But then I might be interested in just looking at Portugal. And so when I click on Portugal, I want to remove all of the other countries, but still retain the context so that I can compute the ranks within regions and within teams. So if we had applied a filter, let me just pop out of here and apply a filter and show you what happens there. So if I apply a filter and then click on one of these, the filter applies first, and then the rank is, because it's a table calculation, the rank is applying after the filter. And so all of your ranks overall in region and within the team end up just being identical as your rank within the team because it's removed the other data and therefore can't compute the rank across it. And so this is not, instead of filtering, what this is doing is updating a set with that selected country. And then the set is just cleverly hidden here. And it's just partitioning the viz by what's in the set, like what's in your selection versus what's out of your selection. And then you can say, well, just hide the stuff that's not in the set, but because hide happens in the order of operations after table calculations, you can still compute the right numbers despite having the appearance of filtering this view. Yeah, no more custom SQL for this. All right, one more, two more examples. One more that I will build from scratch. So here we are, we've moved from player market value to the actual games played in the World Cup here. So this, the view on the left is showing you the number of games that every team played, and then broken down by whether they drew or won or lost the game. And then you can see on the right here whether they scored, or how many goals they scored versus how many goals were scored against them. So now, that's fine as a static overview of like what happened in the World Cup, but the interesting thing is analyzing the relationships between which teams played each other. So if I select France here, it's going to not filter to France, but it's going to filter to all of the games that France was part of. And so then you can see the breakdown of which countries they played, and you can see that they drew to Denmark, and they won, and the other teams lost in all other cases. And then if you want to see, well, what about Denmark? Who did they play? Well, I can select Denmark and then see their breakdown, or Croatia, and now we're looking at Croatia or England. And so you can just iteratively explore the data through relationships and through filtering based on the relationships between these teams. Yes! So this is exactly the same problem as market basket analysis. So show me all orders that had product X on it. It's exactly the same problem as this. OK, so how do we build this? So in this case, we want to look at our different teams, and then the number of games that they played, and then whether they won or lost or what happened. And so now, let me just make this a little bit less massive. All right, that's a little bit more readable. So now we need to capture the selection of the particular team. So I will go and create a set on this. Now note, this is a multi-dimensional set. I don't really want the win. I just want the team, because I want to keep the games they lost as well. So I just delete that. So this is going to be our team set. And so then we can set up actually, I'll do that after. So yeah, the idea now is we have the team set, and so we need to be able to compute the games that were played by that selected team. I don't actually know the IDs of the game, so I have to compute that. And you can do that through a computed set on the game level here. So the condition, this is like not necessarily or not at all intuitive, but let me try to explain. So one game has two records, one for both teams. And so when I click on France, for games that France was part of, one of those records will be in the set, and the other record will not be in the set. So you can then compute the maximum value of the set. So the maximum of true or false is true, because true is like 1, false is like 0, and the maximum of 1 or 0 is 1. So therefore, you can compute the maximum of the team set, and that will then give you the games played by the selected team. And so then, if I drag this to filters, hold on, I had 2 team sets, and I think I referenced the wrong one. Let me do the one with the lowercase. OK. So this is now giving us the games that Belgium played. And so let me delete this so as to not get confused. OK. So now we just need to make it dynamic and set up that action whereby it is targeting itself. So not that one. It is for relationships. And it is the team set specifically that I want to update, because the team set is selection-driven, whereas the game set is a computed set. And so now if I go and click on England, it's showing all of the games that England played. Yeah! All right, now I'm going to show you an example of what else you can do with that. So using the exact same concept, just that core concept of selection based on relationships, I wanted to see how do teams progress from the round of 16 up to the final. So the green tells you the teams that won at that level and then progressed to the next level, whereas the red are the ones that were knocked out at that particular level. And you can select a particular team here, and then it shows you that Croatia played Denmark and won 3-2, and that's how they ended up being knocked out. And so you can eventually see that Belgium and England make it to third place playoff, and France and Croatia make it to the final. Now, it's also interesting to see for a given team, were the teams that they were played, like, did they progress further on, or were they also knocked out in like kind of a next stage? So if I select France here, this is going to show you now the journey of France. My resolution is different than when I built this. It's going to show you the journey of France up to the World Cup. So you can see they first played Argentina, and then Uruguay, and then Belgium, and then Croatia, and then they made it to the final. But now it's also gone and selected those 4 teams that they played, and so then you can see, at what level did those teams make it to. So Belgium made it to the 3rd place final, whereas France knocked all the other teams out. If we look at a team like Brazil, this shows you that Brazil played Belgium, who then went on to the 3rd place playoff. Whereas Sweden played England, who went on to the 3rd place playoff, whereas Switzerland just played Sweden, who was then knocked out in the quarterfinals. So you can actually see how the teams that they played ended up progressing as well. And so that is all done based on filtering the relationships through the game ID. Yay! All right, so just to wrap up here. Now, I have a session following this on interactive statistics beyond set actions. So this was the introduction, and stuff gets really real in that session. It's more on this level, so definitely you're all welcome to come to that for more inspiration on what else can be done. All right, here we go. So just to, one thing I want to say is before you all leave, I view Conference as a lead generation tool for information. So for all of you out there, I'm really interested in understanding what are the unsolved problems, or what are the things that are really hard. I spend a lot of time with our engineering team. I worked a lot with Denny on just showing him all the awesome things that we can do with set actions, and then which led to that eventually getting built. And so I'm more interested in more information that will help us go do more awesome things like set actions. So please get in touch if you are working on any kind of analysis that requires really complex time or event-based calculations or data modeling. If you have scroll bars in your calculated fields, I definitely want to speak to you. Anything where you have lots of data blending, LOD expressions to correct aggregations, you're creating scaffolding tables to make sure that your joins don't lose data. We are going to be releasing an alpha pretty soon of the new data modeling capabilities, and we're looking for testers for that, so definitely reach out. You're trying to analyze relationships and like high dimensional data sets, so sort of similar to that last example with games. You're trying to use Tableau as a calculation engine to do sort of what-if analysis. You need Tableau to be able to invoke, pass a parameter to an ETL process rather than Tableau just purely consuming the output of something like Ultrix. You're trying to build interactive data science applications. You're trying to do something with write back. Basically anything with data I'm super interested in. Like alerting, for example, like what are the rules you're trying to set up? Or you want to use Tableau as a temporary relational cache for web service responses, or just any general product feedback. That's my email. Get in touch, and we should definitely talk. So thank you very much for coming. Please complete the session survey. And